Okay, so today we're focusing on factoring to solve quadratic equations. Okay, and I'm going to show you two more methods after this, because the question that should come up is, what if it can't be factored? Is there still a way to solve it? And there is. So the zero product property says anything multiplied to 0 becomes 0. So if I take 5 times 0, I get 0. If I take 1 times 0, I get 0. 1/3 times 0 is 0. 0 times 0 is still 0. So the zero product property is part of the key for factoring to solve quadratic equations. So here's how it works. If we know that two factors a and b equals 0, then either a or b, or perhaps both, have to equal 0. And so if I have factors that look like the binomials on the bottom here, x plus 1 and x minus 3, then either x plus 1 equals 0 or x minus 3 equals 0. So can you do this mentally? What number would you have to plug in here? -1 would make this equal to 0. If I plug in -1 right here, -1 plus 1 would be 0, so x equals -1. What would you have to plug in here? +3. So that's what's behind it. So we're going to start simple here. And today I just want you to do the now you try problems, and I will give you credit for classwork today. I think you did. Here, anything multiplied to 0 becomes 0 is what that says. Anything multiplied to 0 becomes 0. So I'm going to have you just do the now you try like by yourself today after I do the samples, and that will be your classwork. It is. What's that? It's the binomials. Yeah, when you factor them, they'll be binomials. And you set each binomial equal to 0 and solve it. So if you can factor, this is a pretty easy lesson. So it's a good review of factoring. I'm going to talk a little bit about factoring simple and not so simple quadratics. But before we even get into factoring, I just want to show you how the zero product property works. Now, some of you have seen this before. I don't want you just to go straight to writing the answers. I need you to write down what the zero product property says is true, and that is 4x plus 1 equals 0 or x minus 2 equals 0. Okay, I'd like you to do that first. Otherwise, I find that students make mistakes on either signs or on the division and getting the final answer. So write that down. If you can, from this stage, go through and do it all in your head, the 2 steps, 1 or 2 steps, that's fine. But I want you to write this down first. Here is what it looks like solving 4x. It's like takes us back to chapter 2, section like 2-step problems.
Yeah, 2-step.
2-steppers. Actually, it might have been section 3. I don't know. But subtract 1 from each side. 4x equals -1, and then the second step is divide by 4. And so I've got x equals -1/4. That's one of the solutions. It's one of them. The other solution I can get by adding 2 to each side. So I have x equals 2. And you can go ahead and box them. What I've just found here, just to put it in context, it's like if I had a quadratic equation, I just found that it crosses somewhere, if that's 1 right there, and that's 2 right there, I just found out that this quadratic equation crosses somewhere around -1/4, and then again at +2. So that's what I'm finding, is where that parabola crosses the x-axis, and those are critical points. The next one here, what would my setup be? Yeah, and then we solve each one. I subtract 3 from each side here, so 2x equals -3, divide by 2, x equals -3/2. And then here add 4 to each side. So x equals 4. And I'd like you to try the next 2 on your own. That's it. That's it. So this is the last step in the process of solving. We're going to add in the factoring step on the next page. But just show me that you can use the zero product property correctly to find the solutions I need to use. Go ahead and try those now. Yeah, everybody trying the last few on there. And I'll come around and check them in just a moment. Yeah, good. It looked like you guys got it. So we should have had -1 and 5 on the first one, and then 2/7 and 4/5 on the second. On your work on it. Okay, so let's add in another layer here. Another layer. God. And then I'm going to show you. Yeah, I can show you where the. Eventually, I'll show you where the bottoms up relates to this. So this is a quadratic function or quadratic equation in standard form. We have x squared plus 8x plus 15 equals 0. What we're going to do is start with factoring. So you do not have to do the big X. This is a simple quadratic. I know that because there is a 1 out in front. We are looking for factors of 1 times 15 or 15 that add to equal 8. And you can probably do that without drawing the big X. A lot of you can. 3 and 5. Now, I do not need to divide 3 and 5 by A because A is 1. Yes. So my factors are what and what? 3 and 5. And I write, well, I want them as binomials. So x plus 3 and x plus 5. So when I say, what are my factors of x squared plus 8x plus 15? They are x plus 3 times x plus 5 equals 0. They will be. They will be negative. So with the 0, the reason why those are the solutions are because that's what would make this equation equal to 0. The zero product property says if you put in -3 right here, this term will be 0, and -3 plus 5 will be 2, but 0 times 2 is still 0, right? Wow. Or if you put in -5 for the second one, -5 plus 5 is 0. This other one is not 0. It's -5 plus 3 is -2, but -2 times 0 is still 0. So, no, we don't. Or bad things happen. So x plus 3 equals 0 or x plus 5 equals 0. That's what the zero product property tells us. And then you can see where the -3 and the -5 come from. So x equals -5. So there it is. So we've got an extra layer in this one. You've got to factor first and then solve it. Now, I want to talk about the third of the now you try here because it's just slightly different than the other two, and then you're going to do the other two on your own. So the third one here is a not so simple quadratic, right? It's a not so simple quadratic. So we're going to take 2 times 18, which is 36, and they have to add to equal -15, the middle term. Okay. Right. So what two numbers multiply to equal -36 and add to equal -15?
-4 and 9.
-4 and 9. The -4 and 9 would add up to +5.
Oh, so then it's -4.
Okay, let's start writing them down because we're throwing out wild guesses, and let's do this in a more orderly fashion. 1 and 36, 2 and 18, 3 and 12, 3 and 12.
Yeah, 3 and 12.
So 3 and 12 do work.
What's negative? And negative.
They are both negative. Why do they both have to be negative? Yes. The top's positive, the bottom is negative, so they have to add up to equal -15. And then what do I do next?
You have to divide.
Divide by 2. That's right. Now, finally, we get to see why we're dividing by 2. I'm going to show you right now why that is. So divide by 2. -3 over 2 does not simplify. So what factor comes from -3 over 2? 2x minus 3. And what factor comes from -12 over 2? And -6. Okay, so I have two factors. So the only thing that was different about this one is the factoring was a little more difficult. Then we set each one equal to 0. So 2x minus 3 equals 0, or x minus 6 equals 0. So set each factor equal to 0. And then we've got to solve.
Plus 3 divide that is 3 over 2.
So add 3, we've got 2x equals 3. Then divide by 2, x equals 3 over 2.
And the next one's 6.
And the next one we add 6, so I get x equals 6.
Answer is the number that we accept back.
Sort of. Notice up here the numbers we got for it was a negative 3/2 and a negative 6. Those ended up being the factors, and the answers were opposite signs of those. So that's a good observation. And your observation is why this bottoms-up method works. If I were to start right here with x equals 3/2 as a solution, and I want to move this back so that it's equal to 0. Watch what happens here. Where does this 2 go if I multiply each side by 2? Yeah, it goes in front of the x. See why it's bottoms up? It goes in front of the x. So I have 2x equals 3. Okay, I'm just working backwards here. And then what happens to the 3? It gets subtracted over, so it's 2x minus 3 equals 0. And that's why the bottoms up method works. Is because if you work backwards from the solution and try to figure out the factor, the bottom will come up and then be paired with the number there. And so if you reverse this process, you get your bottoms up method and your solution. So I would like you to try the other two there. There's 2 others. They're simple quadratics. Factor them first and then solve. Yeah.
Are we just writing it in standard form, or are we like solving?
We're doing all everything. So problem 3 is exactly what your skill 16 will look like. You have to put it in standard form, factor it, solve it.
No.
Negative 14, whatever.
Yeah, chill out. Chill out, man.
Maybe, yeah, you got it. So in the middle one, there's an unwritten 1 in front of that p. So on the bottom is a 1. Does have to be negative 5 on the first.
Mr. Round. Get off your phone, Daisy. Look, Sharon. You see it. Oh, bro, Sharon's gonna come tomorrow. You're not gonna like it.
I know.
Look, Cameron doesn't have to be automatics today. Ian, do you have an automatic? Which side of this? Oh no, it didn't.
Where are you? So this one's okay, I'm not there yet.
No.
Should be negative 17.
And how do you do this?
That add up equal that. Okay, where is that?
What? How do you get the numbers?
You said to start going through. You A times C. You know,
A.
What's that?
A.
1.
What's that?
What's C?
14? C said 9.
14. So what's 1 times negative 14? Write that down. And then the middle is B. Yep. 4. 5 and negative 4. So remember, it's got to be factors that multiplied equal negative 20, guys. And add to equal, there's an unwritten 1 right there. So make sure your sign's right or it's not going to work out.
Negative 5. Wait, oh, is it plus 4?
All right, guys, so...
Do you know the Momo challenge?
No. Did you guys get negative 5 and 4?
Negative 5. Yes, sir.
So the
No,
fact,
75 and negative 4. You're a great team.
well, the factors are positive 5 and negative 4.
And
So opposites of those. Yeah. All right, one more step, and this is, guys, what skill 16 will look like, which we will see tomorrow. So Let's see. So tomorrow you're going to demonstrate your understanding of how to solve by factoring on one that's just like this. So it'll have all steps involved. It will be a not so simple quadratic. If you do your homework tonight, you will do well in the skill test. You'll have practice in the math. If you ask me any questions you have, I'm sure, I'm positive. If you do them, I'm sure, whatever. You have to do the homework. You have to do the homework with the purpose of understanding it. So subtract 18 from each side. That's what you're going to do first. You need to get it in standard form. So we've got 4x squared minus 21x minus 18 equals 0. Why are we subtracting 18? Because we're trying to set it equal to 0 and get the left-hand side in quadratic trinomial standard form. Great, yeah. So now, guys, and you have to be really careful with this, because I think why you're, Finn, I like what you're asking. Because you said, why would you do that? It doesn't make sense because there are no like terms over here. That's what you're thinking, I think. But what the reason, you're right, there are no like terms, but we're trying to write it in that form that we were using on the previous sample. Okay? So now it's ready to factor. We do the big X, yep. And we are looking for factors of what? Negative 72 that add to equal negative 21. Oh, we didn't miss this. Did you see the first step we did here? Factor 18 over. Can't check out even for a moment here. So, I don't know, have some of you seen this before? I think some of you have done this? Or is this pretty new?
It's pretty new.
I think Isabel said you've done this before. For a lot of you, I think this is new, but the idea is we are factoring in order to get the solution. So, I don't know, 72's got a lot of options. We have 1 and 72, 2 and 36, 3 and 24, right? Oh, that's the one, yeah, 3 and 24. So I'm going to write a 3 and a 24 here. I'm going to attach a negative sign by the 24. What's next? Divide each side by 4. And when I divide negative 24 by 4, I do get negative 6. So my factors are what?
6 and negative 3/4. So that 2 is just
okay. How do I translate the 3/4 into a binomial factor? 4x plus 3, and then x minus 6. Okay, we there?
Oh, because bottom heads up. Oh,
yeah.
Bottoms up. So it's 4x plus 3 and x minus 6, and then I set 4x plus 3 equal to 0, or x minus 6 equal to 0. So we just keep adding another layer here. But you guys can factor something like this. This is not a problem. If you can factor that using your big X or guess and check method, then you can solve these quadratics by factoring. So then we subtract 3 over, so 4x equals negative 3, divide by 4, x equals negative 3/4. And then this one we just add 6 over, so x equals 6. And those are my two solutions. So I'd like you to try these two here. It's part of your classwork.
The second one only because full answers all time, so.
Yeah, so there'll only be one solution. Only be one solution on the second one. So try those, and then we'll put I'll come around and check, actually. Or negative 7, yeah. It's kind of redundant, but it'll work. So, yeah, the first one there should have been x equals negative 9 or x equals 2, and the last one has only one solution because it's a perfect square trinomial, and that is x equals negative 7. So make sure you have those. It's your classwork points for today. We have one more thing to finish up the notes, and we're done for the day. And I'll come around. I just want to kind of see that you wrote the summary and did this last example, and then I can give you the points.
That's very much around.
All right.
No, I didn't get it. Mr. Round. Mr. Round. Mr. Round.
143 today. It's a little confusing. It's like 144. That's the time I get it. Fourth period. 141 is when lunch gets out. So yeah, I think it's 143.
It's 144. We
Got it off. Mine, it says 143. 143 on Monday.
What's up now?
It's 138.
What time do we get out?
All right, so 143. So we got to finish up in 5 minutes here. So here's a picture. You can see the picture. Look at this picture. Somebody at the lake, the dog, the duck out there. You guys, of course, can't see any of that. But we've got a picture frame around it, and our goal is to get the dimensions, the outer dimensions of the picture frame. And it does relate to what we're studying right now. So we're going to set up an equation. Here's the deal. So the picture is 17 inches, but I've got x on each side of the 17 giving me 2x plus 17 as the length from here to here of the picture. That's 2x plus 17 because of the two x's there. I know you can't see them on yours. Yours didn't turn out very well. But looking up here, what's the dimension of the width going to be, or the height?
11. Just be x plus 11.
Almost, but there's two x's. There's an x here and an x here. So 2x plus 11 equals, the area is 315. So, in the interest of time here, I'm going to tell you what we get rather than wait for you to plug it in. Do you have it already? It's 4x squared plus, you do. You have to FOIL it. It ends up being a middle term of 56x plus 17 times 11 is 187 equals 315. So, you know, in an attempt to make this a real life sort of problem, we get some numbers that are rather large, but it's 3.
Wait, 0.5?
315 is what it should equal. What are we going to do next? What do we have to do? Thinking back. Yeah, minus the 315 from each side. And so we have 4x squared plus 56x minus 128 equals 0.
Can you combine like terms?
You cannot. There are no like terms. But there is a GCF that can be factored out. And when you have an equation, you can just divide through by that GCF, and it goes bye-bye. So I can divide through by 4 here. And if I divide the right-hand side by 4, I get 0. So basically, this simplifies to x squared plus 14x minus 32 equals 0. The difference between this and what we've done before, what's that? 187 minus 315.
Yeah. How is 187 minus 315 negative 128?
Because you find the difference between 315 and 187. Final steps are to find factors of negative 32 that add to equal 14. Can you think of any factors of 32 that add to equal 14? 6 doesn't go into 32. Let's start writing them down here. 32 has 1 and 32, and then 2 and 16.
2 and 7 and 6.
2 and 16.
Oh, wait, yeah.
2 and 6. Okay. So we got 2 and 16. Which one gets the negative?
What about 16 and negative 2?
How about 16 and negative 2? That'll work. So here's the deal. We have x minus 2 and x plus 16 equals 0. So x minus 2 equals 0, or x plus 16 equals 0. So what are my two solutions here? We're running out of time. So we've got x equals 2 is one possible solution. The other one is x equals negative 16. Now, one of these makes no sense in the context of this problem. It's this guy right here.
Oh, you're smart.
Whoa, whoa, whoa. Caitlin, you can wait. Caitlin, just wait. Just wait. It's okay. The bell rang in just a minute. So the 2 works. Okay, just wait, guys. If you take and add 2 to each side of the 17, you get 21 by, if you add 2 to each side of this, you get by 15. So you have to be really, it's like you're holding me to the second, yet I'm here helping you out my stuff. So, you know, let's pay respect.
Thank you, Mr. Ron.
I learned a lot today.
I learned a lot too, actually. I learned more along the shot.
I'm guessing you got 315 by 17 times 11.
No, here's how I got the 15. I added 2 and 2 to the 11.
2 and 2. Why?
It's asking for the dimensions of the outer portion. So it's 11 on the picture,
Yeah.
2 more here, 2 more there, because x was 2.
Oh.
So that's how you get the 15. Same thing here, 19, and then 2 more is 21.
You remember you learned so you sit there, right, figuring it all out at your own pace, and then you just sit there for like a few minutes, like, what do I do now? You can't just get up and grab a book, like, bye.
Why do you have a B minus? I do my homework. I know, I got